Welcome to all of you for our webinar, part 1. Today, the topic is treatment of heating networks with film-forming amines. And if you have any question, please write them in the chat, and I will answer them at the end of the webinar. And so let's start into this section. I hope everyone is seeing my screen. So the topic of today is heating network. So I will start with a small recap of our first webinar season from last year and give some information about the basics. And then we will start into the guidelines and applications for especially heating networks with film-forming amines. And I will show you some case studies at the end. So let's start with the beginning. So maybe you've joined also our webinars from last year, where we did an introduction into the IAPWS technical guidance documents on film-forming substances. You can download them for free at the IAPWS website. And they introduced a terminology which I will use for the presentation, which clarifies what are film-forming substances. These are all the film-forming amine products, and also the film-forming products together. Then we have the film-forming amines, which are the active substances, which are defined as octadicylamine, oleulyl, amine, and oleulamine. And also, there are a lot of different film-forming amine products available on the market, which are contain one or more of the film-forming amines, and in some cases they are mixtures with other active products. And there's a third group of film-forming products which have film-forming characteristics, but they do not contain any amines. And for all of them, it's important to know the composition, because if you want to do a risk assessment or a customization, you need to know what's exactly inside of the products to avoid any misuse on site. Another topic we addressed last year were the analytic procedures. There are also two mentioned in the IAPWS TGDs, which are the Silverstein method and the Bengel-Rose method. Here there are different products and procedures available, for example, for field tests, where I can do a quick sampling directly on site. And there are laboratory procedures available have a very high accuracy. And also there is an online monitoring system available for most of the film-forming amines, which can be used especially for continuous dosing in power stations or high-pressure systems. Also here, it is very important to know the full composition of the product to avoid any misleading results when doing the analytical procedures. And I really address that measuring only the pH for products with alkalizing components or the TOC, this is not accurate in terms of giving a right value and adjust the dosing according to the standards and giving guidelines. You may know how film-forming amines work, but I just want to do a quick introduction in that. So when you start injecting film-forming amines to the system, they cycle around with the water and the steam as they are volatile, and then they start absorbing to the surface, first by a physical reaction, and in the second part by a chemical bonding to the system, which gives a very dense and robust protective layer. and this layer is very stable and prevents, for example, oxygen to penetrate this layer and cause corrosion. And during operation, a multi-layering starts, and that's why it's really important to keep control of the concentration to avoid too strong growing of this layer. If you want to see some more information on that, you can have a look at our recordings from the webinars or the ODACON Insights on our webpage to get more information on this basic use and methodologies, how to apply them. Now we want to start with the topic of today, with the heating network. So in general, it is very important to keep a proper water quality in those heating networks to avoid any kind of scaling and corrosion, because this will lead to failures and stops maybe and leakages, which increases the maintenance and also the operational costs, because these deposits, especially from scaling, have a main impact on the heat transfer. So they reduce the efficiency and they can clog flow path and heat exchangers, which need to be replaced and cleaned, for example. Here, the water treatment of makeup water by softening and demineralization is essential. And in Germany, we have the VDI 2035 and the another document from the Association of District Heating Operating Companies. These two documents include the basic requirements also for makeup and circulation water, but also gives other information about design and pressure keeping and everything. And so I will focus a little bit on the first one, because this is also available in English and makes it a little bit more easy to understand, and the values are very similar. One main source of issues is the scale formation within the system, especially on the heating surfaces and the heat exchangers. And the VDI 2035 requests a softened filling water, so with no hardness inside, especially for the larger systems, which we are mostly dealing with in district heating networks, but also most of industrial applications go into that field. And the smaller ones are for houses and maybe buildings. Any case, we recommend always to have a sufficient water treatment when filling the system, whether you do it with softening or with demineralization. You can use on-site installations or those mobile systems to fill up the lines, because film-forming amines, they cannot provide a sufficient protection against scaling, because this is not the way they are reacting. So fill the system up with softened water or demineralized water, and then from there you can start doing your proper treatment program. Corrosion is a different thing. So as this is happening mostly because oxygen is entering with the filling water, or because the system has under pressure, so oxygen gets into the system and causes corrosion and pitting on several carbon steel surfaces. Also, there are some other types of corrosion which are often taking part in heating system, which can be cavitation or erosion problems, or often also because of a mixed metallurgy systems, bimetallic corrosion between copper and iron, for example. And in some cases also there's crevice corrosion. And in such cases, the pH value has a big influence, but also conductivity, and they are used to keep the corrosion rates under control. In the VDI 2035, there are two different operational regimes, which is a low salt containing system with a conductivity between 10 and 100 microsiemens. This is if you're doing a demineralization for your makeup and filling water, or a salt containing water, which is between 100 and 1,500 microsiemens for softened makeup water. Also, you should have a close look at the pH, especially when you're having aluminium alloys in the system. The pH has to be in a very small range, between 8.2 and 9, to avoid any oxidization of the aluminium alloys. In general, the VDI gives a maximum iron concentration of 0.5 and an oxygen concentration of 0.1 ppm as recommended values. Of course, this makes the use of water treatment chemicals necessary, but especially when you're looking for solid chemistry, for oxygen scavengers, or pH alkalinity builders, they often increase the conductivity, and you can get out of the range or switching from one range to the other. And in that case, film-forming amines can provide a very good support to protect those systems, and they do not affect the conductivity when we are talking on the film-forming amines itself. So the big advantage is that these amines form this diffusion-resistant layer on the on all the piping and materials, and so they prevent the corrosion which is caused by oxygen, for example. So you have these layers which are not only present in operation, but also if you're draining the system or shutting down the system for a seasonal stop, then there is the layer is formed and giving a hydrophobic surface on the top, which does not allow oxygen to enter or water to wet the surface, and this limits the corrosion risk dramatically. The second point is the removal of porous oxide layers. So if you have already some iron oxide layers in the system, the addition of film-forming amine can help to increase the heat transfer and lower also by that the maintenance costs. You can see here some pictures of a non-treated surface with a very rough magnetite layering on top, and after the use of a film-forming amine, this gets very smooth and very thin. So we remove the loose and porous oxide from the top, and just the dense and very thin magnetite layer remains. And this is of course has a big influence on the heat transfer, but also on the flow of the system, because then we have the another issue, because the layer which is forming on the top of the metal is equalizing the electrochemical potential of different metals. So especially when you have a mixed installation, you can see that the corrosion potential with a treated system is much lower, even in the case when there's compared to a blank sample. So you can see here that it's much less compared to the non-treated sample, and even less to a blank sample. So which shows that the corrosion potential, especially with those steel and copper-based systems, is equalizing, and by that localized corrosion is limited to a minimum. Another thing is that due to the formation of this very smooth surface layer, you get a decrease of the corrosion, and also by adding the film-forming amine, the surface tension of the water is reduced. And this helps to increase the pump efficiency. You can see here some measurements which were done with non-treated and treated samples, and the piping was covered with an amine layer, and you can see the change in the flow rate, so, which shows a improvement of the hydrodynamic characteristics and the resistance inside of the pipelines. And another point is that the film-forming amines are biodegradable and phosphate-free products. So they can help to substitute, for example, molybdate-based products and to gain a sustainable and safe plant operation.
Robert.
So,
Robert,
sorry, there was a...
Robert, with how many % did the pump when the surface was flatter, yeah, and cleaned, huh? Do you you are saying that of course then the pump is having less resistance in the system, yes? But do you think that it is really % what you can think that when the surface is cleaner? And did you ever had a measurement done on that?
There have been measurements done, but I don't have the results right here. It depends on the how many deposits are in the system before, and how the FFA changes the surface behavior. So if you have a clean system, then the effect will be less. But in a dirty system, you can gain percent of improvement.
That's interesting. Okay, thank you very much. Go further. I'm sorry for the interruption.
No issue. No issue.
Yeah.
So I've put here some general instructions for the injection of film-forming amines, because even though they are very helpful, they can also cause some problems when the injection is not done properly. So we always do the injection in the main circulation line, not in a side stream or in the makeup water, because there's a good distribution, you have a quick circulation around the system, and so you get a very quick absorption within the heating network when you start injecting in the main circulation line instead of using the makeup water only. Also, it's important to measure the concentration, and we recommend a free or residual film-forming amine concentration between 0.1 and 0.3 ppm to have a sufficient protection of the metal. If you remember, we first cover the surface, and then we can measure the concentration in the system. Also, this injection should be done slow to avoid too strong mobilization. So if you have a dirty system and you inject very quickly a lot of film-forming amine, then you will get a strong cleaning effect, and maybe this will clog some filters or strainers or even heat exchangers because of the very strong effect. So in general, do not do a shock dosing. So we always use a dosing pump with a timer to do a start and stop dose over several weeks. This depends on the size of the system and also on the deposits there, but in general, you can say it takes 4 to 6 weeks. In very large systems, of course, it can take also longer, but don't do it all at once, because this can lead to a clogging in some areas. During this initial process, the concentration in the circulation water should be checked once a week, in the beginning, just to check if the dosing is correct, if there's any need for adjustments to avoid any over or underfeeding. And when you see that a stable concentration is reached, then you can go to a wider spread analytic procedure. So we recommend to do this every 3 months, just to check the concentration, and if it falls below 0.1 ppm, you need to do a follow-up dosing to get it again within the recommendation limits, just to keep the layer on the surface stable, because when the concentration goes too low in the water, then the amine starts to resolubilize from the surface, and so we want to keep it there to protect the surface from corrosion. So that's why we need this concentration of 0.1 to 0.3 ppm. When we start a new system, we always do start with a water analysis of the makeup water, the raw water, and also the circulation water, just to see where the biggest challenges are, and how we can or develop the correct treatment program in for this customer. So if there are no other problems, we start with the FFA injection somewhere in the main circulation line to achieve the target concentration, as mentioned, 0.1 to 0.3 ppm. Often we use standard dosing tanks, and here you can see the small timer with the plug. So the pump goes on for an hour, stops for 2 or 3 hours, and then restarts again. So we can build up slow by slow the concentration in the system. In some cases, we do additional online cleaning with a side stream filtration with a magnetic filter to remove the iron particles from the system. Or in some cases, we also use a side stream softener to get rid of the hardness from the system within the circulation water, so we get a proper water quality outside of the FFA application. And then you just need to monitor the system, do your periodic controls of film-forming amines and the other relevant parameters. And in case it's needed, you can do a follow-up injection to top up the concentration. So I have prepared some case studies. So this is from a local district heating network here in Leipzig, and they did a comparison between the maximum iron levels within 1 year of operation. First with the caustic treatment, so you can see that the iron was between 600 and 1500 microgram per liter, or ppb, and after applying the ODACON treatment, the level was less than 80, and in average it was 40 ppb. So yeah, more or less 10 times reduction of the average concentration of iron within the system. Also, you could see that in over a time view. So in the beginning, you had a quick drop, and then which was related to the start of injection. And then here you can see the mobilization effect. And then again, it goes down to very small traces of iron within the district heating network. Here's another example from an industrial heating system, which is in New Zealand. The treatment was done by our partner in New Zealand, Vicentia. And also here they started a system which was which had very high iron level. So here it's ppm, so 170, 180 ppm of iron, and then it really goes quick down to very low levels. You can see here how the water looks like in the beginning and how it turned clear over time. They also introduced a corrosion monitoring system or with coupons. And so this was the values prior to the FFA program. So the corrosion rate was around 8.6. And after the introduction, 3 months later, it was just 0.5, and another 5 months later, it comes down to less than 0.1 for stainless steel and 0.3 for carbon steel. So a very effective treatment in terms of corrosion. So coming to the end, we can say that film forming amines help to maintain the water quality in heating networks because they prevent corrosion. So even under oxygen presence and in mixed metallurgy installations, they improve the efficiency by cleaning the surfaces and reducing the flow losses. They enhance the system reliability because they avoid service disruptions because of the corrosion protection. Of course, they require monitoring to avoid under, but also overfeeding. And all this together results in cost savings and a reliable operation of the heating network. So I hope you get some new informations, and if you have any questions, please raise them in the chat or now with your voice, or you can contact me afterwards by email or on my mobile number. And please have a look at our website or LinkedIn and YouTube channels to get the latest information. So thank you very much.
Hey, Ronny. Hi, Ronny. I got one question. What's your view on combining FFAs with other water treatment strategies like demineralization or oxygen scavengers? Is it a conflict or more complementary?
So with demineralizations or with the classical pre-treatments like demineralization or softening, there is no conflict. So they are, I would say, mandatory to run a district heating system efficiently. With oxygen scavengers, I would say if you're using film forming amines, you don't need oxygen scavengers because even if there are traces of oxygen within the system, they cannot reach the surface to cause corrosion. So because this is a different view of treatment program, so we can allow some small amounts of oxygen, and protection will also work in that case.
Perfect. Thank you.
Any other questions? No. Okay. So then, thank you everyone for joining. And well, there's another one.
There's another one.
Yes, so this depends on the product you're using. So the question was, are there food grade certificates? So there are, of course, different film forming amine products on the market from our competitors. For our products, we have food grade certifications as we are using a pure film forming amines. So we have no blends and mixtures. And for this, we have a food grade certification according to NSF regulations, and the active compound we use is also listed in the FDA guidelines for water treatment chemicals. So from both sides, we are safe in that case. Another question. Yes, the question was, does it work also for steam and condensate systems? Yes, it does. So this is the the original application is in steam and condensate systems, and it's a volatile product, so it's traveling with the steam through the whole system. And if you're interested in that, have a look at our former webinars, because there we explain how to use it in continuous dosing for flexible power stations or for preservation issues. And also, you can anytime write me a message and I will answer your questions as far as I can. Okay. So thanks again. Hopefully you will join the next webinar as well. It will be in about 4 to 5 weeks. And then we can discuss the next points. So have a nice day, and see you all next time. Thank you very much. Bye-bye.